What we're trying to achieve in today's video is to basically try to understand this particular protocol in which almost the entirety of the whole web is built upon, and it's called the HTTP protocol. We are going to try to dig into the protocol to understand its evolvement, its evolution over the years, starting from 0.9 down to HTTP 1.0, down to 1.1 version, down to 2.0 version, and down to 3.0 version, which is basically built on UDP called QUIC. Now, you might argue that you necessarily do not need to know all of these things, basically because we live in a world of abstraction. Yeah, I think every software engineer should have an understanding of how this basic thing works, because the time would come whereby you would need to do some optimization within your code, especially when you're working on large-scale projects. You might need to move from a particular version of HTTP to the other. So say you want to move from 1.1 to what? 2.0, 3.0. How do you know which one is best for your project? So this is why we're going to be considering these protocols, and we're really going to be understanding how all of this version differs. So your HTTP protocol is actually an application layer protocol, and it is basically responsible for the communication that you have over the internet. The movement of files, or whichever type of files, the HTML pages, whatever it is over the internet, is all being done thanks to HTTP. And the very first version of HTTP is 0.9. We're not really going to be looking at 0.9 version, basically because it was basically a bare bone version. All you can do is you get requests, and you can probably get only HTML files. All right, so we're really not going to touch into that deeply, because there's really nothing to talk about in there. But where it all started is the HTTP version 1.0. Version 1.0 is actually the foundation of HTTP protocol, and version 1.0 was purely simple as well. Version 1.0 was where you have the request and the response model. Pretty straightforward. All right, so let's say you have a computer that serves as our client, and you have a server sitting somewhere in the internet. All right, the way HTTP 1.0 works is, obviously, before you make any form of communication with this server, you need to first initialize a connection, a TCP connection. That's basically because HTTP runs on TCP. Yeah, right. So you need to make some form of TCP connection before you can begin to send request and get response. So you need to make a TCP connection. The connection is what is going to serve as more like a tunnel, right? And within that tunnel, your request and response can flow through. This TCP connection is, if we double click on that a little bit, the TCP connection is basically trying to make what is called a TCP handshake. And the TCP handshake is basically in three ways. All right, so let's say this is our server and this is our client. So the first thing the client does is to send what is called a SYN. Is to send a SYN. And then the server sends his own SYN plus an acknowledgement. And then the client sends an acknowledgement. And this is why this handshake is usually called three-way handshake. Three-way handshake. Don't forget this, because it's going to come in handy. So this is what happens when the client is trying to initiate a TCP connection with a server, and this must happen before any request or response can flow through. All right, so for 1.0, the way it works is, when the client wants to send a request to the server, as I've initially stated, it opens a connection and it sends a request. So let's say, for example, you want to do a get on home.html. So it sends a request to this server and say, server, can you please give me the file called home.html? Let's say the server gets the file. The server then sends a response back to the client. All right, back to the client, giving the client home.html. I wish it was that simple. All right, but most of the time when you have a file called home.html, you probably have multiple images in home.html, and these images are basically links, or you have your style.css, style.css. So when you're requesting for home.html, you would also be indirectly requesting for all of these files as well before your home.html can actually load completely. And what happens in HTTP 1.0 is that a request and a response can only be made using a particular TCP connection. So what that means is, if I'm going to be making a request for image 1, HTTP 1.0 would have to create another TCP connection, right? You would have to create another TCP connection to the server. That means it can no longer use this particular TCP connection because it has been used to make a request for home.html. So it has to create another TCP connection. Now, if it wants to make a request for image 2, it has to create another TCP connection. So for each request and response that is needed to be made, it has to create a new TCP connection. And obviously, you know how crazy this can get, because remember, for every TCP connection that needs to be made, it has to go through this TCP handshake. So this is basically going to bring a lot of burden on the communication. You would have slow performance, obviously, because there's going to be time factor, there's going to be time wasted. That's one of the defects, and I think the most important defect in HTTP 1.0. Hence the reason why we transited to HTTP 1.1. So going to the second version, which is third version, if you will, you're counting from 0.9, which is HTTP 1.1. I think one of the most important feature that 1.1 quickly had to introduce is what is called persistent connection. Persistent connection. So if you've ever seen this particular term called keep alive, if you've ever seen that term, it basically means persistent connection, because remember, for HTTP 1.0, we could not reuse a TCP tunnel. So for every request that we had to make, the client had to initiate a new TCP connection, which obviously is not so good. But for 1.1 version, there was an introduction of persistent connection feature. So if I'm a client and I'm trying to request for a particular page, say home.html, I can easily create a particular TCP connection just once, obviously going through my TCP handshake and the likes, and I can make my request to the server. So say, for example, because I made a request for home.html, and home.html contains image 1, style, my style sheets.css, rather than creating another connection to make a request for image 1 or style sheets, I can reuse the already existing TCP connection, which is this guy. So I can reuse this guy to make another get request for my image. All right, and I can also reuse this guy to make another get request for my style. So that's basically what's called persistent connection. The ability to reuse just a single TCP connection to make multiple requests, and the ability to actually make multiple requests to the server is also a particular feature called pipelining. It's called pipelining. Of course, basically in 1.0, you could not do this. You'd have to create all that TCP connection. But for 1.1, you could use the same TCP connection, which is called persistent connection. But you could send multiple GET requests without having to wait for one another. That feature in itself is what is called pipelining. HTTP 1.1 also had its own issues, and the major issues suffered from is what is called head of line blocking. Head of line blocking. And I'll explain what that means in a second. So let's say this is our server, this is our client rather, and this is our server. Now, if the clients make a request for a particular image, the way it works is, although you can make multiple requests. So let's say this is request 1. This is request 1, and I makes another request. It makes another request, and it makes the third, let's say it makes the third request. So this is request 3. Now, whereas you can make multiple requests, you still have to wait for the response. You can't get the response all at once. All right, the response still has to be sequential, and the response has to come in an ordered format. Right, so the expectation here is we get the response for R1 first, and then we get the response for R2 second, and then we get the response for R3. Now, what head of line blocking basically means is, if for any reason there is an issue with getting the response for R2, let's say maybe there's a packet loss, or there's a particular situation, or there's a connection glitch in this particular request, and we cannot get the response for this particular request. What it means is every other request that is underneath this particular request will suffer. They would have to wait. They would have to wait for R2 to be fixed before they can be attended to. That's what is called head of line blocking. That is a major issue in HTTP 1.1, and of course that causes your website to be slow. If there is a particular image that is having issue, or that your server is unable to load, it means your page is just going to be there static, not doing anything, because a particular image request is unable to load. So that's the problem. That is what led to the fourth version, if you're counting from 0.9, the fourth version, which is HTTP 2. Really excited about HTTP 2 because it actually revolutionized a number of things and made the web quite faster, albeit with its own defect as well. So HTTP 2.0, or let's just say 2. So HTTP 1.1 had pipelining, all right, and the pipelining suffered from a problem called head of line blocking, which I had previously explained. All right, so the way HTTP 2.0 solves that problem is by using a concept called multiplexing. Amongst many other features that HTTP 2.0 was made up of, multiplexing is actually one of the most important, if not the most important. So with HTTP 1.0, the way pipelining works is such that when the client sends a request, the client is able to send multiple requests to the server, all right, which makes a lot of sense. However, because the client needs to get the response in the same order by which he sends that request to the server, the response still has to come sequentially, not simultaneously, all right? So you still have to wait for this response to come before this response can be sent, and before this response can be sent. So that's still sequential, all right? That's still very slow. But the way HTTP 2.0 or 2, if you will, solves that problem is by making both the request and the response simultaneous. And the way it does that is by using the concept called streams. All right. So the reason why we would have to wait in HTTP 1.0, 1.1, the reason why you'd have to wait for responses is because the client cannot identify which response is dependent on which particular response. All right, it's basically a dependency issue, and that's why the response needs to come the same way the request was sent. All right, so the idea here is before the client sends the request to the server, it basically tags the request with a particular stream number. So let's say this is stream 1, all right, and it sends another request to the server. It tags this with stream 2, sends another request to the server. It tags this as stream 3. Now that the client is able to identify each of the requests, when the server wants to send a response, the server does not need to wait for request 1 to conclude, or request 2 to conclude, or request 3 to conclude before it sends the response of any one of them. Say, for example, request 3 was the fastest to get resolved. It simply sends the response back without having to wait. All right. And when sending the response back, it sends the response using the same stream tag. So if after that request 1 had concluded, had done whatever it is it had to do, and now it's sending back the response, it sends this back, and it does that by attaching the stream 1, and then eventually sends back for request 2, then it attach stream 2. Because of this stream identification mechanism, the client is able to resolve its dependency problem. All right, so the client knows that, oh, okay, this is stream 2, stream 3. Stream 3 is dependent on stream 1. Stream 1 is blah, 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 blah. And by that process, we can truly have a concurrent request and response model. And that's what multiplexing actually does. HTTP 2.0 also introduced what is called server push. So this basically goes against the normal way request and response is conceived. All right, normal way request and response is conceived is that the client has to make a request, and then the server responds with response to the request of the client. But what server push basically means is, once a particular connection is established, all right, and the client makes a particular request to the server, and the server responds, the server is able to use the persisted connection to push information, data, down to the client without the client requesting for it. And obviously without the client requesting for it, but it is useful to the client. That's a caveat, not just sending anything to the client. Another problem with HTTP 2.0 is the connection time establishment. Now, HTTP 2.0 requires that you use TLS. And it requires that you use nothing less than version 1.2 TLS. For a normal TCP connection, all you have to do is the three-way handshake. All right, that's all you have to do. But with the involvement of TLS, it further complicates this particular process of initiating a TCP connection. Hence the reason why there is a delay. There might be a substantial delay depending on the traffic. There might be a substantial delay in the time HTTP 2.0 takes to establish a connection. All right. Another issue we have with HTTP 2.0 is TCP head of line blocking. This is truly concurrent, but if there is a packet lost in the TCP layer in this particular request, there has to be an accounting mechanism done to regain that packet that was lost. So as long as that recovery process is on, other requests might not be able to get attention. Other requests will still need to stand still. This is not on the HTTP layer now. This is on the TCP layer. All right, that's what's called TCP, head of line blocking. And that problem, one of the things that led to the movement of HTTP version to HTTP 3.0. So seeing all of this problem with TCP in general, it feels like it can really not be solved. All right, because TCP is a bureaucratic protocol. It wants to make sure that things are ordered. It wants to make sure that lost packets are accounted for. And whilst all of this is good, it also has its own defects, which is obvious in HTTP 2.0. Hence the reason why HTTP 3 altogether ditched TCP and went for UDP. UDP is a connectionless protocol. It is not basically reliable. Hence the reason why we have QUIC. The QUIC infrastructure basically builds that reliability on UDP because UDP is not reliable. So the infrastructure looks like something like this. So we have HTTP at the top layer. We have HTTP 3.0 at the top layer, or say 3 top layer. And on the middle layer, we have QUIC. The full meaning of QUIC is Quick UDP Internet Connection. That's the full meaning of QUIC. So on the last layer, we have UDP. All right, so HTTP is basically built on UDP. We have this QUIC protocol. That has all of the features like reliability, congestion control. You have TLS inbuilt, stream multiplexing being built. It's just a fresh approach to data transfer. Yeah, I think it's one to look out for. It is pretty much still new, but I think it promises to enhance all of the difficulties, the issues that we're facing with the use of TCP as a base infrastructure for HTTP. We'll see how it goes. All right, guys, so that's going to be it for this week. Really, I'm interested to know if you've started to experiment or use HTTP 3 within your real life projects, live production ready projects. Let me know what the performance gain looks like in the comment section below. Smash the like button if you found this helpful, and if you're yet to subscribe to the channel, make sure to hit the subscribe button, and I'll see you guys on the next one. Bye bye.